Hello guys, good evening. Carefully here again, and today it's been a while. So today we'll be doing how to use Excel to solve linear programming. Yeah. So let me quickly open the Excel and then all right. So let's use this to solve for the linear programming using Excel. So first of all, when doing the linear programming with the Excel, what you need to do is first you need to be you have to be able to identify your resource constraints, your objective functions, and then you need to know the normal linear programming style first before you try and then fix them into the Excel, right? So as this question, they said whatever. And there is the equation we came to arrive in. We are maximizing profit here. So we are maximizing profit. Then the profit equation is a 5x1 plus 40x2. And then here's our resource constraints. Constraint 1, constraint 2, constraint 3. Yes, the rest is non-negativity constraints, so they are normal. So what we need to do is first, let's go to it. Then let's first write down our variables. Variables. So we have variables of x1 and then x2. Or we can do it, you can put it in a form of one is desk pro. Desk pro and then portable. Okay, let's put it that way. So for every normal equation, we don't know them. You don't know their values to input for now. So always when you are starting the variables, you wouldn't know their, even though we have some constraints here or whatever, but when we are when you are starting the linear programming using Excel, for them you have to input 0 there, right? 0 will start because we don't know their values yet. But first of all, let's talk about this. Maybe you might not be having, okay, we'll be using Excel solver. So maybe you might not be having the solver, but we will get there, okay. So now we will continue by writing our maximization equation. So maximization. So according to our maximization in this question, It is 50 times x1 plus 40 times x2. So we put that same here. 50 times x1. So we come and then tap on x1. Sorry, I didn't bring the equal to sign. So equal to 50 times x1 to x1, right? Plus the next one is 40 times x2. So 40 times x2, which is this one. You see that x2 or the x2. So our answer will be 0. Let me put, let's say. Right. So this is our maximization. These are variables, our maximization. The reason why it is 0 is because we are multiplying them by 0. But don't worry, Excel will change them to real figures for us. Don't worry. So now we come to our constraints. We come to our constraints. So the constraints are the constraints. Let's go in the question. Let's identify the constraints. So then generate profit of and then maximum hours 150. So the constraints are the assembly and then so the constraints are assembly time and then this high tech currently have only 20 portable displays. So we have another constraint here, which is the display, and then there's no more than 20 units of portable may be assembled. So that one is also there. 300 square feet. So we also have a what? A 300 square feet house. So we have a constraint of assembly and then the display, and then we also have a warehouse. So let's put them there. We have assembly, assembly. We also have display, and then we have a warehouse. And then for the assembly was 3x1 plus 5x2. So the same way, equal to 3 times x1, which is this one. You don't type x1, you come and then click on the cell, right? Plus 5 times x2, x 5 times x2, right? And press enter. Then what was the sign there? The sign there was greater than or equal to. So greater than or equal to. The available was 150. So that one we type 150. You get it. So this sign here doesn't do anything. I'm just putting it there so that I won't forget what I'm doing. So the portable of this thing is also x2. X2 is greater than or equal to 20. Okay. So equal to x2 is greater than or equal to 20. And then warehouse 2 is 8 times x1 plus 5x2. So 8x1 plus 5x2 is equal to 300. So it's equal to 8 times x1 plus 5 times x 5 times x2 and press enter. They are all 0 here. And then it's also greater than or equal to 300. And have our non-negativity constraint. Non-negativity. Non-negative. So you have x1. Yes. Equal to this one. Greater than or equal to 0. Greater than or equal to 0. And then x2 also greater than or equal to 0. Sorry, greater than is here. Sorry. All these are less than. Sorry. Only the non-negativity. Yes, and the non-negativity constraint is the greater than or equal. The rest are less than or equal to 0. So now we are done formulating. What we need to do is now put them in the Excel server. So we need to come to data, and then you see this server here. That's what we are going to use. But some people might not be having the server. So you come to file, and you come to, I think, is it option? Let me see. Yeah, it's options, right? And you come to add-ins. Click on add-ins, right, to bring you here. So you will see server 2 pack here. You see it in it. So once you see it, this server add-in, right, you click on it and then you click on go. Then it will be added. You click on OK. Then it will be added to your data. Okay. So that's what you are going to do to bring in server. So now, after downloading the server, you click on the server. Pull it here. So they said they are asking for the objective function. So now you click here, you clean everything. You come and then this is the objective function. This is what we type in for the objective function. So you click on it, enter. Oh, sorry. I say enter, sorry. After clicking on it, they remove on to setting the objective. We are maximizing profit, so it's to be on max. If we are to minimize profit, it will be on min, but we are maximizing profit, so it will be on max. So now we come to the changing variables. The changing variables are the variables that will be changing, which is the one that we don't know the value. So now we come and then put our mouse on it here, and then scroll down. So the two of them, so they will be here as we are seeing here. Right. And now we come and then add our subjected to constraints. So these constraints, we are coming to add them here. So we click on add, and then you come in here. It's already in less than or equal to, so it's already there. So less than or equal to, you can also, you understand. You click on add the next one. It's also this less than or equal to, it's already there. And then we come and then click on it, add again. And then we come and then choose the warehouse to less than or equal to, it's already there. And then add our 300. Click on add. Then we come to our non-negativity constraints, which is this. But now we will change it to greater than or equal to, sorry, greater than or equal to 0. Click on add. Then this one again, we change it to greater than or equal to, and then we click on 0. And then click on okay. This is our final distance. So this is it here. These are constraints. These are changing variables, which is this ones. These are changing variables. And this is the maximization. Here is it. Right. So now checking here, then bring we change here to simplest LP. Right, simplest LP. And then now we are done with everything. We just click on solve. Then we select sensitivity here, so that we will get our sensitivity report, right? So we click on the sensitivity here, then we click on OK. You remember here was 0. Here was 0, 0. Now look at it here, 30 and then 12. Here was also 0. But look at it here, 1980. Here was also 0. Here was 0. Here was 0. Here was also 0. What are we seeing? They've all changed, as you can see. But here did not change. Here did not change, but here have changed. You get it? So now let's enter into the sensitivity report. So now this is the sensitivity report. We have the final value. So the final value in here is the optimal value. This is the optimal value in the in the visibility region. This is the optimal value that we can produce to maximize profit if we were to be using the graphical method. So if in case a question is given and you see this sensitivity report and they ask you, what are the optimal value for this report? These are then the 30 and then the 12. These are the optimal values. And then these are the optimal values. Right, these are the optimal values. And then we have the reduced cost. So the reduced cost affects the optimal value. So let's talk about the allowable increase and decrease first. So the allowable increase is how far you can increase your objective function without it affecting the final value. So here we can see that you can increase your dex pro by 14 and it will not affect the optimal value. But when you increase it more than 14, right, it will affect the optimal value. Here too, we can see that you can increase your objective function by 43 and it will not affect the optimal value. So when you increase it more than 43, it will affect the optimal value. You get it? So let's say if they tell us that they ask us that if the objective coefficient for portable is increased to, let's say, 85, will it affect the optimal value? Yes, it will affect the optimal value because 43 plus 40 will give us 83. So if it crosses that one, then it means it will affect. So when they ask us that, when the objective coefficient for portable is increased to 75, will it affect the optimal value? We can say that no, because still 75 is still within the 40 plus the 43. You get it? So coming here to the allowable decrease is also how far we can decrease the objective coefficient without it doing what? Without it affecting the optimal value. Sorry. So here we can decrease it by 26, and then it will not affect the optimal value, right? We can decrease it up to, so when we decrease it more than 20, so let's say when we decrease it by 27, it will affect the optimal values, and then yeah. So here too, we can also decrease the portable by only 8.5. When we decrease it more than that, like let's say 9, 10 or something, it will affect the optimal value. So that's what it means here. That's what it means here. So the reduced cost also signals that how can we reduce the cost of the coefficient so that the optimal value won't be. So the allowable increase or decrease normally talks about the production, and then the reduced cost talks about the cost, how we are to increase or decrease the cost what do we say, to affect the optimal value. So basically that's it. So when we come to the resource constraints, this is the constraints. The constraints are here. The constraints are here. So the constraints are here, as you can see. So note that the reduced cost talks about the cost. Allowable and decrease, we talk about what? The production, which is the quantity. Yeah. And then we have the constraints here. The constraints here is also the warehouse. So we know, so when the right-hand side is equal to the left-hand side, we know that it's what? Binding. So basically, you get it. If the left-hand side is equal to the right-hand side, we know that it is binding. So here, when they ask us that, which of the constraints are binding constraints? So we can say that warehouse is a binding constraint because the left-hand side is equal to the right-hand side. We can also say that assembly is a binding constraint. So the left-hand side is equal to the right-hand side, right? But we can see that display is what? It's not a binding constraint because the left-hand side is not equal to the right-hand side. You understand? So talking about the constraints too, right? Here we can see clearly. Let's first talk about the constraint for the house. So it means that we can increase the capacity of the warehouse by 100, right? And it will not affect its final value, which is its optimal value. We can still produce additional 100 and still, like the warehouse, no, like best to normal inside of, and we can also decrease it by 66.66666, and then still have what? A normal warehouse. You understand? Like it will be like we won't be in a loss as in total. Can you give me some minutes? We will be in a loss. Okay. Okay, I am Racco for Racco. Okay, that's it. Okay, so that's it. And then we can also look at the assembly constraint. We can also increase the assembly constraint by 25. and it will not happen, nothing will happen to the final value of the optimal value. And we can also decrease it by 35, and then it will not affect the optimal value. The same here, display what the 1e30, it means 1 exponent 30. So it means that we can increase the display by a large amount of quantity, and it will not affect the optimal value. We can increase it, but when we decrease it by 8, it will affect the optimal value. That's what it basically means here. So when we increase it by 50 billion, it will not affect the optimal value. But when decrease it by 8 per, it will affect the optimal value. You get it? This same year, 1 exponent 30 was also saying, say we can decrease it. So basically, this is what is this what how do I even put this one? Okay. This so far what we have to know in the sensitivity report. But what I've known so far is, because the lectures did not teach us, maybe it might not be coming in our exams. But me, I like to at least have an idea about everything, so that if in case it comes, I can do at least something. Yeah. So you can see the sensitivity report was so fast. So this so far, there is it. So you can now come back to your tab, your sheet here. If in case they ask you for the maximization, the profits is there's it 1980, and your values, your optimal values is this and this, right? And then your constraints are here. So that's it. That's it for this part. So from next week, next week here, next week we'll be starting probability, so that we will catch up with the class. Thank you very much for watching this video. Bye.